G'day and welcome back. So I wound this coil, it's got a very small wire, to try and build something that this magnet would be repelled, because the bigger ones I couldn't get to do the job properly, those ones. So I used much finer wire. And so I've got our signal generator here, a little one. We can turn him on. And what I found was, with our two knobs here that I use to refine the duty cycle and the gain and the sensitivity, that is, that didn't matter what I did, it didn't work. And we're running at 6 volts, 100 milliamps. I reckon that should have worked. But because it is a DC pulse, nothing's going to happen. And indeed, nothing does happen. So what I decided to do to find out the minimal amount required to repel the flux of the magnet was to just use our power supply directly to the coil, and I'll show you the result. And what I found is I could run it at 12 volts and 50 milliamps. Got this set up. There's our air gap, there's our north facing magnet, there's our coil, and all I do was just with the negative just tap the coil, and you can see it's repelling the magnet. Every time I touch, it's strong enough to, see, just like that, strong enough to repel that magnet. So that tells me that's all that's required from our signal generator. Now, the second thing I considered in relation to this primary coil here, which cuts off the flux, is that it has to be an LC circuit. So that has to be, it's not even warm, that has to be an LC circuit, because that will then excite these other coils, which we make exactly the same. That's why it says in here, I'm sure, that all these pickup coils have to be exactly the same as this main coil here. So then I thought, well, how do I find in my situation the resonant frequency of that coil? And so I come up with this idea that I think you'll find interesting at a certain level. Now, what I came up with was using this speaker to find the resonant frequency of this coil. And although it's only an audio wavelength to find the resonant frequency, I found it interesting that I could do that. So I'll show you what I did. So basically I'm running this at 6 volts and 100 milliamps through our signal generator, and that's attached to our speaker, and I'll demonstrate it. And what I found here was that when I put something on top of that speaker, like our coil, then by holding the coil and adjusting the knobs, you could actually feel, when you touch it lightly, you can feel when the coil resonates. So I'll demonstrate. Turn on. So I can't feel it resonating there. That's resonating there. I can feel it resonating. Really hasn't changed the resonance. So you can actually feel, you can actually feel the point where the coil vibrates, and that's very interesting. So then I thought, well, if that's the audio, frequency to cause that coil to vibrate, could I also find out from a magnet's point of view? So I put a magnet on there. You can feel it vibrating. Change the frequency, and you can feel it really vibrating there. So that's really interesting. So I don't know, tell me your thoughts. What do you reckon? And what I found out, to get that coil to vibrate in resonance, what's the lowest I could go? And it was pretty much 6 volts, but 10 milliamps. That's all it took for that to get that to vibrate. You can hear when I hold it, it changes. So that's really low power consumption. So then that begs the question, can we use that really low input to then induce the other coils, but still needs to be strong enough to counteract the force of the magnet. So there's got to be a common ground between those two somewhere. The question then begs, can we make the magnet that has the same resonant value as the coil by adjusting the size of the magnet? So therefore its ability to resonate will occur at the same frequency as that coil. You see where I'm going with that? Then the question came about, and I spent a lot of time thinking about it, and I want to know what you think, is this theory. So here's our magnet, and our flux lines go from north to south, right? If it'll sit there. And all places in between. So there's our flux lines. And it occurred to me that when we vibrated the metal, when we had the resonant frequency of that magnet, it was only the resonant frequency of the material that it's made of. And it's the same with this coil. When we found the resonant frequency of this coil, it was the resonant frequency of the coil material, the gravity of the thing, the size, shape, the reactivity of that to the sound waves. My theory is this, and someone can tell me what they think about this. The ability to vibrate that magnet using sound is one thing, but what about if everything has the ability to vibrate at a certain frequency? The actual flux itself should have that ability. You should be able to vibrate that flux, the actual frequency of the flux itself, using some method. And there's got to be a mathematical equation for that, depending on the strength of the flux. So take out the physical, take out that physical magnet and the physical aspect of a coil, and just focus on the magnetic flux. What's the resonant frequency of the magnetic flux that both of those emit? I think if we can match that, then gee, you'd be onto something. Absolutely. How do you know when you've found the vibrating frequency of the magnetic flux because of the physical attributes of the magnet and the coil. You think you might have that frequency, but it might only be the resonant frequency of the magnet or the coil. It might not be the frequency of the magnetic flux. See where I'm going? So yeah, I'd love to hear what you think going forwards. Yeah, all pretty interesting. So I reckon this thing really can work. It really can. If you get all those things in alignment, the resonant frequency of the magnet, the coil, the resonant frequency of the flux, and then that stems and goes down the line with all these pickup coils. Absolutely, I can see it generating a lot of power. Let me know what you think. Thanks for watching and catch you later.